Hi everyone, welcome back. Today we are going to do MCQ from one-tail test and two-tail test in hypothesis testing. First let me give you a small recap. See, one-tail test means you are just checking that your sample statistic is significantly greater than or less than the population parameter in one direction only. See, you are just checking one direction. Here you are checking left direction. It may be right direction also, but not both together. Just take an example. Let's say you have discovered a new drug and you just want to check whether the new drug reduces recovery time or not. Okay, so you are just checking whether it reduces or not. You are not checking whether it is increasing or not. Okay, so only one part. And this is, you can see, this is a normal distribution. And this green region is the acceptance region. And this red region is called critical region or rejection region. So once you set your hypothesis, null hypothesis, alternative hypothesis, then in second step you take significance level, and from that you calculate what is the critical Z value. See here, the critical Z value is 1.64, the black one. So this one is critical value. If your calculated test statistic, here the calculated Z is -2. So if your calculated test statistic lies in this region, in this red region, then you have to reject null hypothesis. Right? Same way you can do it for right side also. But the main point is you are considering for one side. That is why one-tail test. Clear? Now what about two-tail test? Simple thing, you are checking both the region. This is the acceptance region, but see, this is the critical Z. This is plus 1.96 and minus 1.96. See, this one. Sorry, this one. Plus 1.96 minus 1.96. Okay. So if your calculated value lies here or here, then you reject null hypothesis. But if it lies here, then you do not reject it. Okay. So in this case, we are checking both the side. Here also, here also. Example, let's say you are giving a training to some students and you want to say whether this training method is improving their average score or not improving their average score. So you are checking both the side. Let's say you are applying a teaching method on a group of students. Now you want to say whether this teaching method is improving their score or it is decreasing their score. I mean, if their average score is 85. Now you want to check whether it is increasing or decreasing. Simply we can write not equal to 85. So you have to check both sides. This one also, this one also. Then you have to go for two-tail test. Okay. See, here the calculated Z is lying here. So we can say that we accept null hypothesis. Okay. So now let's do the MCQ. So what is the main purpose of one-tail test? Main purpose is to test if it is equal to specific value. No, we are never checking specific value. Is greater than or less than a specific value in one direction. Exactly. So it may be here or it may be here also. Both cases, this is one-tail test. Okay. When would you use one-tailed instead of two-tailed? When you have no prior hypothesis, no, there should be hypothesis all time. When you are only interested in detecting an effect in one direction. Exactly. Now, in one-tail test, where is the critical region? Critical region, I have told you, this is the critical region. Right? So, in one test, where? Split equally in both, that is for two-tailed. Entirely in one tail? Exactly. At the center? No. There is no critical? No. Critical region will be there. What is the main purpose of two-tail test? To test if it is different from a specific value in either direction. Exactly. To test if it is greater than a specific value, then it will go for one-tailed. Less than one-tailed, no effect? No. When is a two-tailed test appropriate? When the direction is unknown or you want to test for any difference. Exactly. I want to know whether the teaching method improves the score or not. So that case you will go for two-tailed test. If in two-tailed test, where are the critical regions located? In the both side. See, in the both tail. So at the center, no, entirely in one tail, no, split equally in both tail. Okay. What happens if the test statistic falls in either tail in a two-tailed test? Then you reject the null hypothesis. They want to say this is your normal curve, this is critical region, this is critical region. They say the test statistic like Z, T, chi-square, ANOVA, whatever it is falling in one tail, either tail. Here also it may fall, here also it may fall. If it falls in any side but in the critical region, you will simply reject. That is the acceptance region. And this portion is rejection. If it is here, reject. If it is here, reject. This is the critical point. These are the critical region. Okay, so we have understood. This is a very simple topic. So meet in our next class. Bye. Happy learning.